Topic for today's session is we would like to talk with you about the fundamentals of linguistics for search applications. What actually is important, what needs to be covered. We're doing this with two people here. We're mixing in between, so my colleague is sharing the center part of it. But before we start, perhaps just to put some context around it. What do we mean with fundamentals of linguistics, so that we are all a bit in line with what the expectations are. What we are not going to do is to talk about all the fancy stuff like the NER, the sentiment analysis, entity relation extraction, not these pieces. We just wanted to focus on the core basis, the foundation, where all these kind of features are building on top of. And I hope you will see also in the end that there's also already many things you can do in order to add a lot of quality into your search application if you start focusing on, let's say, basic things already to get things started. In addition, obviously, the others are also quite important. Agenda for today is, of course, why should we care about linguistics? Why are linguistics important? Obviously, that needs to be covered. What are important languages, by the way? So there's also different views on that. So what is important? Challenges and pitfalls, what's available in terms of implementations, and wrapping it up in the end a bit. So quite a lot of things to cover, especially for the challenges and pitfalls and what the important languages are. So let's get started. So my name is Christian Vogt. I'm working since 15 years now in the area of delivering search solutions across various technologies, so search implementations. And in our projects, we see linguistics always, at least being required to be touched upon. And we would love to do even more so, because really the quality can make a difference here if you start looking at linguistics, and we're tuning these in our projects and also for the clients. With me is Bastian. You would like to introduce yourself?
Yeah, am I on?
I think.
Am I
Now you're on.
Okay, so I'm actually working in the same company. We say about it, a word about it in a minute. Working for 10 years in delivering search solutions and more or less in all kind of aspects of search solutions. I also have a background in computer science, but I'm especially interested also in the linguistic and linguistical stuff, and I'm very happy to talk about that today.
Okay, so quick word about the context on what we do. Our main focus is on search, while we also do cloud and collaboration stuff. And for search, since 2001, our organization is focusing on delivering search solutions end-to-end to our clients, and also augmenting with knowledge transfer. So factored in what you may see later on here during this talk is also all the experience that we gained out of the projects here. So just that you know a bit of the context on how we look at things. I think that's usually makes a difference. But let's get right into the subject matter here. So why should we care about linguistics? And looking at this from a use case perspective is actually, we're living in a global world, for sure. It's not all about English content, so user groups are multilingual, really. And that holds true both for the intranet and also, of course, that's obvious for public search implementations. It's also, content is created in different languages. Even though you search for it in English, it may have been created in French, in German, in Japanese, or Asian context. So that's also something to take care of, usually. It's a different kind of a problem rather than just a technical thing to solve. Queries are also formulated in different languages, and it's hard to actually infer the query language if you're just throwing a keyword in front of a search engine without any context. So that's also something you need to take care of. And even more complicated, content may be created. For me, for instance, as a non-native speaker, I'm German, in English, and that makes a difference also in terms of the wording and how you can look and search for it compared to an American person creating English content, or even compared to a UK person creating the content. And that also may make a difference for queries, since you may query a bit differently for the more sophisticated pieces. So with that said, that's actually the content framework. And from here on, I would like to pass over to you, Bastian, to drive it further now down towards the techniques, what needs to be done.
Okay, so, yeah, so let's do a very little recap, just logically. Most of you know, or probably all of you know, how is a search engine built? Well, you have an inverted index where you have a list of words or tokens here. Can I? Yeah. And you have some kind of posting or document list, what it's called. It depends on the search engine. But basically, you say, I have a token here, and it's available in this document and in this position word-wise, and normally you also have byte offsets because you want to do something like highlighting and so on. Of course, it's not that easy. It's differently encoded to save it efficiently, but just from a logical standpoint, and for us now it's very important to see how do we get to these tokens. And this is, as a first step, even more difficult than it first looks like. So let's get a small example. Most of the examples are quite artificial, I have to admit. But let's say we have the sentence here, Montreal more beautiful than Washington, D.C. So what does the computer see in the first beginning? Well, this byte order here, of course. And we somehow have to get to tokens. Yeah? Well, an easy idea is to split this sentence like on white spaces. That's often done. You see that you have some difficulties, like you have interpunctation characters here. You may split on every non-alphanumerical. That's another idea. You get rid of this, but for this Washington, D.C., this is semantically, this is one word. Like now you split it up to D and C, and that's tokens that are not very valuable in search because they are single letters. This is maybe solved quite easily, rule-based. So there are rule-based tokenizers that get this right, get the interpunctation out, keep abbreviations together. This is kind of the easier part, but this is yeah, just as a start, you somehow have to get from a byte sequence to a list of tokens that you can use in your inverted index. And then let's take this a step further. Now we have a sentence like Washington, D.C. is a younger city compared to Montreal. It's actually I wanted to do it otherwise, but it's this is the truth. What now if you search for young city, and there's no young as a token in this sentence here, and well, you somehow have to get from younger to young. Yeah? If you want to search for young city, you probably want to see Washington, D.C. here. This is very simple, but what was you search for Washington, it's written with a small letter at the beginning. It's a simple, it looks simple, but it's of course another token. It's another byte sequence. Yeah. So normally would end up indexing normalized tokens like this one. They are all lowercase. There may be accents removed. And here adjectives, verbs, whatever may be reduced to their normal form. And this is something we want to look at. And also we want to look at for different languages in the following and see what the pitfalls are. A little bit of a framework where we talk about. So in search you normally define two measurements, precision and recall. So precision is how many documents, if you search something, and if a human would sort your documents, if they are relevant for the search or not, how many documents in your results are relevant compared to all of your results. So stated otherwise, how many garbages in your search result that you wouldn't see as relevant if you sort your results manually. And also recall means basically how many of the relevant documents in my index or my corpus are in my search result that I would consider relevant for my search. So this is how much is coming back. And yeah, they are sometimes combined, but normally they are contrary. So it's quite easy to configure your search to increase precision and thereby decrease recall. So easiest way to increase precision is probably just show the first result. Most of the times it's relevant, but the recall is very bad. And the artificial solution to just increase recall is just always show every document in the index. Recall is, of course, very good, but the precision is very bad because there's a lot of garbage in it. And what so if you optimize your search, you often want to stay like here. So you want to increase recall and not too much decrease precision, or you want to increase precision and not too much increase precision, but not too much decrease recall. And this is something you always have to think if you do something to optimize your search. Yeah. So normalization, of course, increases recall and decreases precision, but if done right, it's very near to the axis, I would say, and gives an overall better quality and results. Some example, you normally would do a normalization for case, so lower casing. We have a city in Germany called Frankfurt am Main. This is the Frankfurt you know, if you know one Frankfurt. And if you lowercase AM, it could also be time of the day. Yeah? So you lose some of the precision there, but that's normally in an acceptable range. As this talk is more about language than about technology and the pitfalls of different languages, and we're going to want to have a quick overview of what are important languages. As you might guess, English is winning most of the competitions, but it's interesting what's next, and English is not winning all the competitions. So one measurement may be what are languages on websites, just as a general idea, what are important languages. Of course, yeah, more of half of the websites, at least in 2017, were English. And yeah, there are maybe languages you expect next, like Russian, Japanese, German, Spanish, and so on. French, sorry, I'm in Montreal, so I should mention at least that one. Or this is something, what is the default language users have set in their browser? You now see Chinese moving up a lot, German moving down a lot, unfortunately. Arabic is in there. You have something that you don't have on the content side, like Indonesian. These are important languages of, let's say, internet users. And just as a stolen from Wikipedia, just the distribution of native speakers. Of course, now Chinese is at the top. But yeah, you see kind of important languages. German is out now, unfortunately. So let's have a quick walkthrough through some of the languages and see what's difficult in normalizing these languages and what are maybe pitfalls you can think of if you optimize your search for that language. So first thing you normally have to do is if you want to do some normalization, you have to know what language your content or query is in. That's the very first step. And sometimes for the content side, it's provided by a source system. But if not, you have to detect it. And what you normally do is you have distributions of n-grams. For example, trigrams here. OK, that's German, but it's quite easy. You always take overlapping 3-letter tokens. And then you just count in your document or in your query how much this happens. And you have a distribution per language that you saved somewhere. And you can say, well, this is nearest to this language. That's quite OK if you have a long text and it's only in one language. That's OK. Then this works very well. And it doesn't work very well if you have short text. And where you have short text is the search query itself. It's very short. It's very hard to detect the language of a search query. And it gets really ugly if you have text with multiple language in it. Yeah, you can have a text that is German and English. And then you have to combine these distributions of n-grams in these languages, and the result may be closest to Portuguese. But there's no sentence of Portuguese in the document. So you probably have to split it up by language. One thing that often helps, if you have a language detector and you know I can only have German, English, and French content in my repository, then restrict the language detection to this language, because then it's not possible to have another language that just may be overlapping or something like this. And next thing is tokenization. This is the second thing, because sometimes you need the language to decide how to tokenize. And this is also the reason why you can't detect language by words, because you don't have to words. Words you only have after the tokenization process. So yeah, here's some examples here in German. So we had this example with AM already. You normally want to keep such abbreviations together. You want to get rid of interpunctuation. That's rule-based, or at least you can, and this is what's implemented in most search engine right tokenizers that work for most European languages. We get other examples soon. There are special cases like the elision, so the removal of vocals. Yeah, so you have articles here that are contradicted to the noun. You probably want to index something like this, so revert this. You have this in English too, where you don't want to index these normally. That's, for example, very, very fun part. It should say Frankfurt is not a beautiful city. I'm pretty sure for Japanese, I hope for Chinese. What I want to show is that there are spaces missing. And these are two, or probably the only languages I know that don't write with spaces, but unfortunately they are very important, as we saw before. These are really important languages if you are in a multi-language environment. So now the task of breaking your text up into token or into words get much more interesting. It's kind of easier for Chinese as there's no flectation, so there are no grammatical suffixes or endings. You can go through this with a dictionary. It's even more difficult for Japanese because you have grammatical endings here, the negation, and the base form is different. So they flectate, or they have grammatic forms like most European languages, and they don't have spaces. So this is an interesting case. If you want to support it, you can't just do default and not take care that you have Japanese content. There's nothing useful coming out of that. Next thing maybe is character normalization. So maybe you don't want to keep the characters you have one-to-one in your token list. We already saw lowercasing, which is very common. But accents are very common too. So yeah, this is French, just some random sentence grabbed somewhere from the net. But you see that there are a lot more accents than in English or in German, for example. Or we have umlauts, that's one kind too. And what you may index is this one without accents. But this also highly depends on if your users are native speakers or not. Yeah? So in native French speaker will not make this wrong, but I would. So you have to think about who is searching, what are your users, do they know the language? Just an example, this is translated from this with Google Translate, so maybe it's wrong, I don't know. But Vietnamese has a lot more accents even than French, and they stack them on one character. So this is maybe also a good idea to normalize some of the characters. We have this in other languages like Arabic. These dots here are vocals. So normally they left out. It's a consonant writing system. And these vocals are only in learner texts and in the Quran, as far as I know. So you may want to normalize that if you have text with vocals and text without vocals. It's semantically the same. You want to find something, no matter if it's written with vocals or not. Some languages, like ours, had the great idea, or not the language had the great idea, but the people to kind of reform the language in a Big Bang approach, which Germany does, or not Germany, Germany, Switzerland, Austria did in 1996. So afterwards, a lot of words were written differently than before. So if you now have old content and new content, and you don't want to have this as a natural barrier, but you want to find old content with new queries and vice versa, you have to think about normalization. And maybe you don't even succeed on a character basis. In this case, yeah, sorry, I wanted to, yeah. So it's photographing dolphins. So dolphin was written with PH before, and now it's written with an F, and taking photographs too. But there are more words that are written differently, or with more letters, and so maybe you even need a word mapping if you want to be really good at this. That's one of my favorite, actually. We kind of settled on UTF-8, I think, in the meantime. Yeah, I don't know about East Asia. They were a bit more reluctant and maybe have more Shift.js or GB Big 5 character sets. But I think in a multi-language environment, most content, or we can agree that the content should be in UTF-8. And so maybe the encoding problem is solved by now. But really, it isn't even in UTF-8, so, or inside UTF-8. So you have this German word über here. It's the origin of the taxi company's name. And well, this is 7-bit ASCII. That's unspectacular. But if you take the U umlaut here, you can encode it like this, 2 byte. That's the preferred or normal way to encode an U in UTF-8. You can also write a normal U and then put 2 dots on it. And that may happen. It's not the preferred way to encode this. But if you have and I don't talk about fonts. It looks exactly the same. You have a Unicode capable editor. You put them in 2 lines under each other, and you think it looks the same. Why does it find it? And you really have to look at it with a hex editor to see that these are different tokens for a search, and you won't find the one with the other. You have to normalize it if you want to catch that. That's also nice. Yeah, hello is the German hello. It's not that different. And this is just 7-bit ASCII. This is very nice. It's Latin characters half width in Japanese writing, so known as Romanji to Japanese. It looks exactly the same. It's Latin characters, but they are encoded differently. They have an area in UTF-8 where they can encode Latin characters in Japanese text. And if you have Japanese text with English words in it and they are encoded like this, you have to normalize this. There's a filter in Solr, for example, for that. And now we are a step further on the semantic side. So now we have all this encoding and character stuff done. You want to get rid of grammatical forms or grammatical endings. And the first thing is what you do is stemming. So this is basically, you have an algorithm that cuts off suffixes, grammatical suffixes, and leaves a stem, which is not by itself a valid word. So you have 2 problems. Advantage, it's fast and it's easy. It's just a small program. Of course, per language, this is very language dependent, of course. But you have some problems. You can have what's overstemming. So a typical example in English is university, universe, universal. They are by a bit more aggressive. I think the S could still be here. Well, I don't know. By a bit more aggressive stemmer, they could be stemmed to the same stem. And then if you search for one, if you search for university, you get texts about the universe. That's probably not what you want. It's overstemmed. You could also do understemming, so you don't reduce the semantically same word to the same stem. So if you have mice and you just want to cut up some grammatical suffix, you won't get to mouse anywhere. That won't work, yeah? So stemmer would probably leave mice as mice, and if you search for mouse, you don't find the texts about mice. That's a shortcoming. Yeah, and it doesn't give, as I said, a valid word. That may be relevant if you do autocomplete or did you mean on the basis of your index. I once had a customer that always complained that they get Apple without an E in the end as a did you mean suggestion to their customer in an e-commerce context. You shouldn't take the stems for your autocomplete, but valid words. Another thing, lemmatization. The wording stemming lemmatization is a bit different. We define it normally like this. Stemming algorithmical lemmatization is based on dictionaries. Normally, so you have to have a dictionary for every word, but the advantage is that this reduces also irregular forms to the base form, and that you have valid words as a result that you can index as your base form. There's Handspell in open source that more or less does this. It has difficulties too, because it's not built for lemmatization. It's built for spell checking in OpenOffice, LibreOffice, Firefox, whatever. And it only, from what this was built for, it only has to decide if a word is valid, not what's the ground form. It's more or less a side effect that you can use this for lemmatization. But sometimes you don't get the real base form because it's not necessary to have this correct. It's just necessary to have the words correctly identified as valid words. Another example, again, from German. There are some other languages that does it too, Dutch, Finnish. we can combine words to very large words. So if you would write multiple words after each other in English, you can combine them to one word in German. So this is, I should have tried to translate this. So this is a captain of a company that drives steam boats on the river Donau here. Donau Dampfschifffahrtsgesellschaftskapitän. And so it's a lot of words connected, and even more, sometimes there are character inserted. So Schifffahrt is shipping or something like this, not in the parcel sense. Captain is here, but there's an S inserted if you connect these two words. And this you have to algorithmically get rid of. And there are also examples, but I don't have good examples I can explain in English. There are also a few examples where the decompounding isn't unambiguous. So there are multiple ways to decompound a word. And this is a bit similar to Japanese-Chinese tokenization, as they don't use spaces too. So we normally use spaces, and the Dutch and the Finnish, but not for some words that they combine. And you can either leave it like this, or if you want to be able to search for Donaukapitän and find this word, you have to break it up for search. So that's a problem too. Something that's more or less in the case of linguistic is synonyms. So something like rich and wealthy, you may want to normalize this to one, so you find it one and for the other. It's bidirectional or unidirectional. This increases recall, but I've often seen it misused to overcome shortcomings of lemmatization and did you mean. So it's like a silent spell check or something like this. You have to be careful of this in your maintenance of synonyms if you use them. A quick look, because it should be more about, there is a lot of difficulty in different languages, but a quick look what software is available. All search engines have tokenizers and character normalization also for different languages. If you look at all the Solr filters, there's a lot of stuff like Elysion, what we had with this vanishing vocals, like normalizing Japanese Latin characters to normal Latin characters and so on. It's all available. There are stemmers available in different forms, like Porter's Nova stemmer is very popular. In Solr, there are light stemmers that are less aggressive, so they don't overstem that easy, but they understem, of course, easier. It's always, there's Handspell, where you have to download the dictionaries, but Handspell itself is, for example, available in Solr, so you can do lemmatization with these spell check dictionaries. There's quite some Chinese and Japanese support in Solr. That's quite okay with pre-built models, at least for the Japanese one. A really hard thing is this decompounding stuff in German. There's not so much available in open source. You have to see if you can build something for your corpus or not. And of course, there are commercial packages like Basistech or mostly smaller competitors like the Spanish BTEX that build software for linguistical analysis. And you can integrate, but of course you have to pay for it. But then these are built, in contrast to Handspell, these are built for lemmatization and not for spell checking. You get better results. I've done projects at the customer where we replace Handspell with something commercial, and search results get better. It's really something to look at. Sometimes they are used in commercial search engines or OEM'd. I think this is already your part. So.
Yeah, so thanks, Bastian. I mean, hopefully we're able to convey a bit what the intricacies are of dealing with languages at the core foundation. It's not that we all need to take care of them on our day-to-day business. That's being taken care of, as he said, even with Solr and the open source foundation, it's all there. But I mean, conceptually, we have to think about them, right? So on the various layers. So it's important to think about languages beyond English, what we need to support here, and how are we going to solve it. And yeah, eventually, taking care of linguistics, we always hear we need more relevant results. Dealing with linguistics properly also helps you getting more relevant results, because it's not only about relevance, it's not only about tweaking the parameters and the weight, it's about setting the whole search system up in a proper way so that you're catering for those. So you may want to ask yourself which languages are to be supported for my users? What do I have here for a public website? And there are various views and how you can get to them. You may inspect your search logs, where they're coming from. You may have a good idea of your organization or so on. Various signals you can take in order to determine these.
And all is the wrong answer. Yeah. So you have to pick it language by language. Yeah.
Obviously, it's also about balance if you're dealing with the language for the stemming piece, overstemming, understemming, these type of things. Then also, one of my favorites is, are the users native speakers? They really do search differently. And are they searching for, am I searching for English content now as a non-native speaker? Then maybe also, if you look at a solution like enterprise search, CMS systems may compose content or maybe published for the various corporate languages in there. Which item do I want to present? And so that all goes together here. Are users perhaps even trying to search in a language they don't know at all? So is there any means, thinking beyond linguistic, that I can support them with, like make a suggestion or so perhaps? Can you rephrase, opening something like direct translate functionality somehow, or make it somehow obvious that you detected that problem, that you can support them? And yeah, eventually, on the technical level, you would want to understand what is available in my technology, what's available in Solr, in Fusion, whatever you have. To what certain level of degree may I take that, if I look at? You can do a lot of things by looking at, for instance, tuning via dictionary uploads, blacklisting, whitelisting, reducing the amount of languages that you're indexing, that you're trying to detect during ingestion to the set you would like to support, just to rule out the things you don't want to see in here, to increase probability of detection. And if you even want to go beyond, you may also obviously integrate during ingestion time and query time. That's also important to state. It needs to go together. If you do something in ingestion time, it must match what you do with the query at query time, right? If you don't normalize at query time but do at indexing time, it won't match in the end also. So what's available there? You can augment iteratively and improve from there, but it's really like going through all these layers. What the use case, the business perspective around these, what are the users, and then going all down through these layers. And it really makes a difference. We've seen that in where we were really tuning this, that it makes a difference for the quality of the search results that are being returned to the users. So key takeaways also that we would like to convey here is that you need to take care of this on a per language basis, really. So that's one of the key building principle here. Each and every language is different. So which language need to be supported on a per language basis, you would have to optimize and to see whether we are good or not so good. Yes, it does make a difference on quality. I mentioned that. And last but not least, yeah, it's really content query-wise, what are the most relevant languages we have to think about. And now that we are in America, it's more like the English world here still, but also we are working with many international companies spread around the globe. Oftentimes it's non-native speakers, and I think the language stats that showed quite nicely, the way you look at it, it's really different. Looking at the frequency that users actually speak Chinese, Spanish, and then English comes somewhere compared to what's being used on websites. And yeah, you may want to answer that question for your use case properly and take that before you perhaps even start about tuning all these weights next to your parameters here for relevancy. Yeah, and I think that's it for the session. In case you have any questions, feel free to ask. I'm not sure how good we are in time.
We have 5 more minutes. So
we have 5 more minutes in case there are any questions.
Yeah.
Yes?
About normalization, do you have a recommendation? Is it still better to use ICU or OpenNLP, or is there any other library available to improve normalization?
Mm-hmm. Which kind of normalization?
Most of the time, it's to remove the accent or to remove a weird white space, because we have a lot of characters in UTF-8 that can be a white space.
I think that there are quite specialized filters in Solr also. So I would use that or I would prefer that to OpenNLP, for example, which uses trained models. And most of this, like white space accents, can be done algorithmically without machine learning and models. Yeah. There are, of course, cases like if you take this Japanese tokenization where you work with models again, but there's specialized. So there's quite a lot of filters in Solr and in Fusion, of course, by that you can use. And yeah, otherwise look at Handspell. Look at something commercial. I don't think OpenNLP really helps on the basic linguistic. They have NER models that might work, but also Stanford NLP is quality-wise much better for that. Yeah? But yeah, I would look. It's basically looking at the filters that are available. There's so much available, but you have to configure it for your use case. You have to see what language do I support, and in my language fields, German text, English text, French text field, you really have to think about which filter to use, and this also depends on who's searching: native user, native speaker, non-native speaker, and so on. But there's a lot of technology in for example, Solr. I would first look at that.
Perhaps one additional comment. Nowadays, also more like natural language processing is getting towards the query box, right? With these kind of voice recognition technologies for putting queries to a system, that obviously helps the system and you to detect the language because you're getting more context and you're moving a bit away from these single words. Could be, in special use cases, also a technique to improve on the language detection, obviously.
Does Solr have anything out of the box that allows you to detect tokens that do not belong to any known languages? Like for example, our search index contains a lot of patent documents. Sometimes you will find like chemical compound names and very exotic, like proper, like pharmaceutical like terms.
Mm-hmm.
And typically they do not belong to like any languages. So sometimes we are like tempted to just remove them from our search index because that often causes the problem of blowing up the term index and then degrading takes up our like storage space and also degrades our query performance. So I was wondering if there's anything that allows you to detect whether a given token belongs to like any language at all. Do you have any good suggestions for that?
I don't know anything, so I haven't seen anything like this. The normal or the traditional mean of language detection with n-grams doesn't work on single words. Yeah, they are the shortest way you can or the shortest text you can have. So this is out. So I think you basically have to have a list of common words in each language. At least for European language, they are available from some universities that collect these most frequent words. But then the long tail after that is too long, and they still belong to a language. So that this doesn't really help too. Yeah. So yeah, that's a hard problem. I don't know of a solution.
But are these really words the users aren't searching for, so that you can safely ignore them from the index?
Well, it's really case by case. Like we had some users who were reporting that they need to search on these strange words. Some were considering them as pretty much the garbage data. So we're kind of sitting on the fence.
Yeah.
Kind of have to satisfy both sides of the fence. But I'm just like
Yeah.
wondering whether it is actually possible to filter out all the non-language tokens.
I mean, in the end, I mean, if I look at how the query language is detected, you're throwing in a keyword and you get back a probability of what language that should be. So, but applying that to at the ingestion part for each and every word, that's
Yeah,
probably
that doesn't
not so
work.
ideal,
That doesn't
right?
work. It's too small.
too
Yeah.
costly.
So I don't think there's a solution for that other than stop words, but it doesn't work. You need it the other way around. So you don't want to remove certain words, but you want to keep certain words, let's say. But then you have to have more or less complete word lists of your language to keep only these, and they are large. You can't keep them in memory. Then it gets slow. I don't know a good solution for that. Yeah, I would just keep them in the index.
It could.
So whatever.
Did you try entity extraction or recognition for these words?
I'm not really good in that area.
Okay.
Usually defer to like
Because that could be a different topic. I mean, it mustn't be necessarily linguistics, but entity recognition.
I think we have to
Spectrum
close, so we are at 0.
We can.
Okay, so if
So,
you have any
yeah.
questions, we are around tomorrow too.